Okay, let us carry on.
Hello. Okay.
You go too fast already, you got lost. I've decided after every topic, give you a assigned homework to do, assignment to do, so that I can mark for you.
Like the previous chapter.
Yeah, like the previous chapter. But I see that you're not doing your homework, that's all. Okay, there's one more focus 15 that we have. I have a bit of problem last week. Where is it? Okay, essay question. Number 1. Can got there. Question B. A is all right. We have done already. We have some calculation mistake, but other than that, the equation is correct. You got 2 cells. 1B essay question 1.5, 0.5 ohm. Right? They don't draw for you. You just imagine it's there. And then the other one is 3 volt. Internal is 1.0 ohm. Connected to 3 resistors. 1, 2, 3. Find one current I1, I2, and I. Potential difference across CF. CF is here. Right? It's normal. You have to get the 3 equation. First, usually it's just take a junction, either this junction or that junction. Right? So look at this junction, what is going in? I1, I2 is going in, what is coming out is I, Kirchhoff's current law. And then after that, a loop, you got 3 loops. This loop, and then this loop. Okay, so it's up to you to choose. Instead of 3, just choose 2. So you got 1 equation. So loop A, right? A, B, C, D. So I'm using anti-clockwise. Right? Sum of EMF is 1.5. Right? Same direction as this arrow. Sending the current that way is 1.5. Then this one, the current is same direction as what we take. That's why we plus 5. This one also same direction as the current. So that's why it's plus. Then if you can simplify it right here by 5. Right? I'm just taking this the other side by 5. By 5 0.5. By 5 0.3. And then I need this one to be 5. So I multiply by 10. Call that equation 2. Then loop. This one. E D. I'm taking clockwise this one. E D C F. So in this case, 5 times there's your 4 plus 1 is 5 times your I2. And this 5 times your I. The EMF is 3. So now I'm replacing your I2. Right? Because here it's up to you the way you do it. Right? Here I got I and I1. So I want to replace I2, depend on which equation you are solving. Right? So there are many ways to do it. But I just choose to replace this one I2 with your I minus I1. So I put that one in 5I minus 5I1. 5I plus 5I is 10I minus 5I1 minus 5I1. The 3 is still there. So that is your equation 3. Right? That's the reason why I times 10 here. So that I can add these two together. Equation 2 and 3. 3 plus 2. My equation 1. I want to solve that. So 1 plus 1, 2 plus 3 is 2 add together. 10 and 10 is 20I. Plus and minus, this one is 0. So 3 plus 3 is 6. And after that, you can do mentally or use calculator. And from 2, that's my equation 2. Instead of using times 10, I use this one. 0.5 I1. This I take across there. 0.3 minus 0.3 is 0. Okay, then I can use this one to find my I2. Right? This equation, same thing. Okay. Your I1 is 0. So I2 equals I1, I. Now we are supposed to find the potential difference across CF. So it's just the current times that resistance. Okay with that? Any question?
Wait, so you just straight away do V equals to IR.
Yeah, that's the current. Current times that resistance is the potential difference across CF.
Oh, across CF.
It's
only,
just the
not
potential
V.
difference across the 5 ohm. Same thing. Yep.
Okay.
Anything else you want to ask for this topic?
No, I think I should do my own revision first, then ask you doubt.
Yeah,
No
you
point
better
I
go and
ask
revise
you.
and then do your first assignment. Make an effort. Learning is yours, not me.
Hey, Che, you think I can do it?
You have the will, you put in the effort. I think you should be able to make it. Now, don't put the effort like what you have been doing. You come for tuition, it's a waste of money.
Yep.
Right? You have to put in the effort. You have to start now already. No time to waste already. You still got time to put in the effort and learn. I can't learn from you. I can only try to do my best to teach you. Okay, we are all right. Let's go
Yeah,
to
right.
any question?
No.
No. Okay, let's go to the other one. Checkpoint 16.2. Force on moving charge. Why? You're sick?
No.
Okay, let's go to checkpoint. This author is, we have, there's a book that we're using. It's quite a good book. If you have been taking the trouble to do it, and this is probably an old author, have been in the market for, I think, more than 30 years. Probably is an old teacher. Okay, for each of the following, mark the direction of the magnetic force F, if any, in acting on the charged particle moving in velocity v in a magnetic field. So this one is a positive, probably a proton, right? Moving in the direction of the magnetic field. So where's the direction of the force? Yep, that's the direction of the force. That's your Fleming's left-hand rule.
For A, Che.
For A, it takes so long means you have not been doing your homework. You have not been doing your homework at all. So how to progress? You tell me. There's no force.
Wait, there's no force.
There's no force if it's the same direction. Only where it's at an angle, then there's a force. How about B?
Force downwards.
How can it be force downwards? Up or down is occupied by V already. Left to right is occupied by the field already. So it's either in or out. You have to use your Fleming's left-hand rule.
Oh, out.
Out? Are you sure?
Out.
Are you sure?
Yeah.
Force is out of the page. Okay, good. Right? That's your, sorry, this is a positive charge. Sorry, my fault. I draw the wrong direction. I thought it was a negative charge. So the current is that way there. Right? Same direction as the current, the positive charge. Okay, how about this one? Remember this is the electron, normal positive charge. Yep. Use your Fleming's left-hand rule. Right? There's your force, there's your
This
field.
one C, right? Yeah.
Yeah, we are doing C. We're doing C.
The force upwards.
It's either upwards or downwards because your field is coming out. Dot means coming out. Right? Okay. They means left-hand rule. I said that the current
Wait, tell me again. Dot means
it's coming out.
Means coming out.
The arrow tip. Arrow tip. Field is coming out. So in this case, the current
X means
going to the left.
X means coming in. X
If it's
means
across,
coming in.
like here, it's going in. This one is coming out.
Okay. Yeah.
Okay. So it's upwards. Yeah, the force is there.
Fleming means they have left hand and right hand rule, right?
Right hand rule is for induced current. Don't get confused. Don't get confused. Left hand rule. Right? If you have forgotten, use a vector rule easier.
We use left hand rule lah.
Use vector rule easier. Vector rule is just that way. That's all.
Rule.
That way. That means V cross B. Right? You put your direction in your from V velocity, move to B. Move to B, then you get your thumb is your force. Okay, how about the
Thumb
donkey?
Is the force.
Donkey?
Where coming out. The V thing is going down already, so it's either you can go left or right. So coming out means usually will be right lah. Yeah, force to the right.
That's your current. Sorry, what am I doing? I tend to get it all wrong again. Yeah.
To the right, the force.
Yeah, to the right, you're right. Good. That's the current. The positive charge is the current. Positive direction of the motion of the current. So you are right. Yeah, know how to use the left hand rule. Okay, let's go for the right to the right. Correct. Okay, diagram shows the path of charged particle W, X. Sorry, there's a W, there's a Y, there's a Z, Z or Z, whatever you call it. Determine the in a uniform field radii of curvature of W and Y. W is this one, Y is this one. Right? They are the same curvature. That means same radius, but half the radius of X. Right? That's your X. Half the radius of X. Determine the sign of each of the charges W, Y, and Z. Okay, what's the sign of W, Y, and Z? Yep. Use your Fleming's left-hand rule. This one you have to practice until you get it right. You cannot afford to lose smart. This one you study that in your STPM.
Fleming left-hand rule, okay.
Yeah, Fleming's left-hand rule.
Wait, sign means they want it in answer in what, positive or negative, right?
This one you must, like W, you have to determine the direction of the velocity. So the W, that's the direction of velocity. Because of this arrow, it's coming in. Your field is going inside the page. So where's the direction of the force?
W is positive.
W is positive, then
Z is negative.
Z is negative.
Y is negative. Correct.
Y is negative. Okay, let's see. That's your V.
Okay.
Right?
W
That's
I
your
said
velocity.
positive, Y and Z I said negative.
There's your force, Z. So that one, you just use your Fleming's left-hand rule. If you get it, the direction of the force that way, then you are right. And Z, that is your velocity. Right? The force is that way. Apply Fleming's left-hand rule. If you get the force in that direction, then you are right. Velocity is that way for Y. That's your force. So W and Y are positive charges. Z is negative. So you are wrong for Y. Okay.
Wait, why wrong for Y?
Y is positive. You say
Oh,
negative.
you have to determine the V and F also lah.
You have to determine the direction of the force. That's the direction of the force. If
Yeah,
you got the
direction of the.
Fleming's left-hand rule, your force is to the left, then it's a negative charge. So from here, you can determine already, roughly.
Wait, force to the left means negative charge means then Y is negative lah.
Why? That's why Y is negative. Yeah.
No, but you said if F is to the left.
In this case, if my F is to the left, then it's positive charge. If my F is to the right, then it's negative charge. Use your Fleming's
Why
left-hand
like
rule.
that?
Use your Fleming's left-hand rule. Your field is going in, so it's the correct direction. If you take it as
Isn't
positive
it coming
charge,
out?
field is going in. X means going in. You see
Dot,
the arrow tail going in. Field is going in. Arrow tail.
dot is coming.
Dot is
Coming
coming
out.
out.
X is coming in.
Arrow tip.
So
Remember
X is
that?
coming in.
You see the arrow tail there. The cross means arrow tail going inside. Dot means coming out. You see the point of the arrow. Okay.
Okay.
If W and Z and X, that's your W. That's your X. Have the same speed. Find the ratio of the specific charge of W to that of X. Now you can see that if you don't do homework, I have to go with you one by one so that you understand. It's a waste of time only. Right? What is specific charge? Yep. What is specific charge?
So you're asking for
Remember,
B, Jeff.
what is specific charge? I ask you. You
For
must know.
positive and negative lah.
What is specific charge? What does it mean by specific charge? You must know that before you can calculate what is mean by specific charge. Cannot answer means you have not studying your work I'm teaching you. That's why I say yeah, waste of money. Q over M.
E over M, yeah.
Or E over M. Charge over mass. That is called specific charge. So what is your answer?
Two.
Right, let's see. Right, always derive. No point in memorize. There's so many formulas. So your magnetic force equals your centripetal force. And one specific charge is S is Q over M. So you want Q over M, take the M down. V can cancel off. You still got one V here. Take the B down. Right? So your specific charge Right? Take this one down. You got Q over M. Then V and V cancel off. You still got one V. dr. That's your specific charge. Right? So for W, is that one there? That's a W. Radius, and let it be R. Then X is this one. Your told is double the radius. Same formula. Double the radius. Correct? You are right. 2. Okay with that? Good. Now make sure you do your homework. Okay, let's do number C. If the magnitude of
Back again. Okay.
if the magnitude of W and Y, there's a W, there's a Y, are equal, but the speed of W is twice that of Y, compare the mass of W and Y. See, playing the formula, that's all. Right? That means you want the mass of W divided by mass of Y. What's the answer? Yep, can. See, the formula, that's all. You want mass now? Know what is constant? Get rid of your constant. B, R, and Q are constant. Different speed, that's all. Right? The field never change. The charge never change. Right? So you just want your MV, that's all. Yeah, so the radius of Y and W are the same. Yeah, radius of W and Y are equal. So it just your variable is M and V, that's all. Play with the formula. Right? So mass of W times velocity of W, mass of Y times velocity of Y. Right? They want you to compare. So take the ratio, take My down, take VW to the other side, cross multiply, and put in your value. The answer is 1 to 2 or half. Cancel your V. So you get half or 1 is to 2. Can? Anything not clear? Yep. What's the problem? What's the problem?
Wait, so you don't even have to involve the R, is it?
R, yeah, those same radius, here. Same radius.
Oh.
You can work with the formula lah. That means you can find your M and then put in to me. I see it's unnecessary. You cancel your P out, cancel your R out, cancel your Q out. It's a lot of complicated, cancelling and then make them confused. It's better to remove all that by getting this formula NV equals to constant. Get all the constant to
No
one
wonder
side.
I couldn't solve the questions.
Okay with that?
Okay.
The diagram shows a proton with a speed. That's a proton. The speed is given in a direction perpendicular to the uniform field B of magnitude is given out of the plane of the page. show on diagram the direction of the force F on the proton. Right? I give you the answer already. The force is there. Right? Since you have seen the circle there, that's a circle. So that must be the force. And the subsequent path of the proton. Sorry, I am the one who give you all the answer. Sorry. I am the one who give you all the answer. Should have removed all the answer. Can you get the direction of the force? Yeah. Play means left hand rule. The field is coming out. There's your current or velocity of the positive charge of proton. So can you get your F? Using your Fleming's left hand rule, that's the direction of F. Yep, can or not?
Yeah, can.
Can, okay. Then after that, you're supposed to subsequent path of the proton. So it can either be a circle. That's the force. So it must be clockwise. Can be either this curve or this arc there. Depends on your mass and speed. Calculate the radius, circular path. So as I said, no point in memorizing the formula. You can memorize, go ahead. But there's so many formulas. Go back and derive it. Right? Magnetic force is a centripetal force. And then there's your radius. Right? Cancel the V and then take the R across, take the D and Q down, and put in your value. Right? Mass of proton, data sheet, if it's not given, then use atomic mass unit. Okay, if that value is not given, atomic mass unit is 1.66. Right? The speed, that is your speed or velocity. And then your B is there. Charge, either you memorize it or get it from your data sheet. Value of constant, then calculate out and put meter or put in cm. And part C, an electron move with the same speed in the same direction in the magnetic field. State and explain two differences between the path of the electron and the proton. Okay, what are two different? We have to upgrade it 10 minutes time. Yep, what are the two different? Okay, only use this formula to explain. They ask you to calculate radius, use this formula to explain. No? Yep, what is the difference? If it is an electron, imagine this is the electron. Yeah, you'll never be studying. That's why you cannot answer the question.
It's C, right, sir?
Yeah, we are doing part C, replacing that positive charge with the electron. So what are the two differences you are expected?
Electron is charged negative. Magnetic force on electron is on the opposite direction.
So if we deflected to the left, there's one different. What's the other different?
Mass of electron is smaller than mass of proton.
Is that formula? Right? Mass is smaller. Right? Electron will deflect to the left. Being smaller mass, radius is also smaller. Right? Because your R is proportional to M, smaller mass. Right? V is the same, charge is the same, Q is the same, so it's proportional to M, that's all. Okay, that's all you need to talk, two differences. Okay, I think we might stop here and then we go to a new section, next 40 minutes. So we might also take a short break. Any question you want to ask? Anything to clarify before I stop? Anything? Anything not clear? Yep. If not, I'm going to stop now.
Okay.
If okay, let's stop now.
So stop now.
Yeah, I'll stop here. Give you 5 minutes break
Okay.
and we will carry on.
Okay, how many hours class left, sir?
2 hours, maybe slightly more, but it's okay. Won't charge you for that.
2 hours.
Because you want to finish it one subtopic. Okay with that?
Wait, no. So you're telling me the class another 2 more hours, sir?
Another 1 hour only, slightly more, another
Yeah.
less than 1
yeah,
hour,
that's what I meant.
another 40 minutes.
Okay.
Okay.